Hi, welcome everybody for the MATLAB session. Today we're learning about transpose and complex conjugate transport in MATLAB, how it will work, how we will found transpose and complex conjugate transport. Okay, so first we will see what are the built-in functions are there to find the transpose and complex conjugate transpose in the MATLAB. There are two built-in functions. One is transport and C transpose. C transpose means implies that complex. Okay, complex number matrix. If you have matrix like complex numbers, then what transpose function which will be performs like generally in the MATLAB that we will see with examples now. So actually the operator symbol is this for transpose, for general transpose. Okay, in the MATLAB in the academic years textbooks we will see the transpose matrix for the matrix, right? So that is performs by dot single quotation mark, the straight line single quotation mark. This will perform the normal transpose of the matrix. Okay, and this will perform complex conjugate transpose. Okay, the role of these operators will perform in this way. Okay, and built-in functions are transpose and C transpose. And how we will use this? For example, A is a matrix like any size like 1 by 1, 1 by 2, or 2 by 2, 2 by 3, 3 by 2, any size of matrix like square matrix or rectangular matrix, whatever the matrix. If you want to find the transpose matrix means, so this is the simple transpose built-in function, we call it as a syntax. And if it is like complex conjugate transpose, now just single straight line quotation mark is enough. If you want to use the built-in function, that is C transpose, we must use as C transpose. If we don't know transpose and C transpose, we don't know, at that time what we will use, the same operation will get performed by this type, like this type of operator. If we use here, A is a matrix as we used here, and is dot and single line quotation mark, it is a operator. This operator will perform transpose of matrix A. So here B is the transpose matrix of matrix A, and this dot single quotation mark is the operator. So here also same. If we see A is a matrix, for example, and its a complex conjugate transpose is a B matrix. Okay, we are taking A and finding the complex conjugate transpose of matrix A with the operator single quotation mark. Okay, so B. We will see this in the next slide. What are the examples of it? Before that, we want to know about the single quotation mark and what is complex number, right? So this we call single straight line, straight single quotation mark. Okay, so generally in your keyboard or everywhere in the text typing, everywhere we use curly quotation marks like this, curly quotation marks like this. Okay, like this we will use. But in MATLAB, even you click this single quotation mark na, it will take like same, the straight single quotation mark, it will take like, because in the MATLAB we don't have this curly quotation marks. It will take by default as a single straight single quotation mark. Okay, okay, that is about this, where we can found in the MATLAB. You no need to worry, you use your keyboard, and that is telling single quotation mark, double quotation mark, that will take automatically in the MATLAB. Okay, complex number, that is in the form of a plus ib or a plus jb. I've written here a plus ib or a plus jb. That means I and j, both elements, the both letters in the MATLAB will take as a same thing. Okay, that's why I've written here, see, I is equal to j is equal to root minus 1. This root minus 1 also can be written as bracket of minus 1 power 1 by 2. So this we will see this, we will prove this whether it will true or not in the MATLAB. Okay, right, this is the MATLAB window. So first of all, I am checking I is equal to j or not in the MATLAB software, how it will treat I and j in the complex numbers. I, okay, what it is showing, 0 plus 1 I, and j also I am writing. What it is showing for j, it's also 0 plus I. So I and j will treat equally in the MATLAB software. And also I written there I equal to j, okay, and this is root minus 1 value. It is equal to root minus 1 value. So I am taking this value. I will show that this value is equal to I and j. Okay, I am taking this value because a root, this symbol I cannot write in the MATLAB. Instead of that, I can use bracket of minus 1 power 1 by 2. Okay, that I am going to do now. So now I am writing bracket of minus 1 power of power of 1 by 2, right? 1 by 2, 1 by 2. Okay, I am clicking enter button, then it is showing 0 plus I, 1 into I, 0 plus 1 into I, 0 plus 1 into I, 0 plus 1 into I. That means I is equal to j is equal to minus of power 1 by 2. That means root minus 1. This value is exactly equal to root minus 1. Okay, we know this. Now we know about complex number and this quotation mark. Okay, now we are going to some examples. Okay, right? Yeah. So transpose and complex conjugate transpose. Okay, transpose. Magic 6 I am taking. M is equal to magic 6. Okay, like M is equal to magic 6 I am taking. Like, yeah, I can write it right. Yeah, magic 6. Magic 6. Magic 6. So magic 6 is shown like it result as 6 by 6 matrix. Okay, see here 6 elements in the column and in the row, and sorry, in the column, and 6 elements in the row. That means 6 columns and 6 rows. 6 columns and 6 by 6 matrix it is generated. Okay, so for example I am taking that M is equal to magic 3, magic 3. Okay, what it will do? 3 it will do. 3 by 3 matrix it is generated. So you see here 3 it, here magic 6 we are taken, right? So what is the greatest value in this matrix? It is 36. Okay, 3 we are taken, right? What is the greatest value here? 9. I will take for the better understanding another one, magic 5. Okay, what it is shown? 25 is the greatest value here. That means a magic syntax will generate a square matrix with the elements from 1 to, with the elements from 1 to square of that value. Square of that value. See, for example, 5 I have taken here. 1 to 25 values it will take, and it creates a square matrix. I taken 3 here. 1 to 9 values it will pick and it will set in a manner to create 3 by 3 matrix. For example, here I have chosen 6. 6 into 6, 36. 6 square, that means 36. 36. 1 to 36 values it was selected, then created one 6 by 6 matrix. So that is the magic function that will work like this. Okay, now I am taking M is equal to some other I will take now. Magic 4, magic 4. 4 by 4 matrix is done. What is our purpose here? We are learning about transpose, how it will work. Transpose, right? So M transpose matrix, M transpose, that I am clicking here M and giving a dot and single quotation, giving a dot and single. See here, right? I am clicking enter. Now transpose matrix is resulted. See here, 6 2 3 13. Here 6 5 means the row, the column is become as row and row is become as column. That is the transpose. Row will become as column, column will become as row. Okay, these values all are integers. There is no complex number. It has all, this matrix have all integers. There is no complex number, right? For this integer matrix I am given this transpose function. Okay, transpose function. Okay, I am writing the syntax that we have to use. Syntax, no, what is the syntax we have? Transpose, transpose, right? Yeah, transpose. I am taking this syntax. Okay, I am taking this syntax to MATLAB. Okay, now mat M transpose with function m transpose with function I am taking. So this is my function. Oh wait a minute, I will take here, yes, transpose. I am giving that, what is m, right? M give it. So this function dot single quotation mark, straight single quotation mark, and transpose function, both will result same function, both will result same function. Means the where we seen the transpose function, built-in function, and this single quotation, this operator will give same result. Okay, either way we can write to find the transpose. And second thing is, to test this syntax and this operator function, we have to use complex matrix for the better understanding. Okay, now I am closing all this by using our better click. What is that? Clear all, close all, CLC. So everything is closed. Now I am creating a new matrix, that is M, with the complex numbers like 2 plus 1i. Okay, first element 2 plus 1i, completely single element, not two elements, it's a single element. And 3 plus like 4i, and yeah, it's your wish, I am just taking for the example to show. And 3 plus 2i. Okay. Okay, if you give this quotation, it will take single element as single. Okay, so I am taking, this is first row of three element. I'm going to write 3 by 3 matrix. Okay, first three element completed. I am taking 0 and 0 and 3. This is second row elements, and third row I am giving again complex numbers, 7i and 9 plus 1i, and last number I am taking 0 plus 5i. Okay, yeah, right. I close this. So this is my matrix. What happened? Oh wait. So here colon I didn't taken, right? That colon should be there. Colon. Now I will click yes. So this 3 by 3 matrix is created. In the 3 by 3 matrix, you see this is 2 plus 1i, 3 plus 4i, 2 plus 2i, 0, just I, because it is 0 I have taken. And you see, these are complex numbers, but I didn't enter these three elements as a complex number. But by default, MATLAB is taken and showing it to you as a complex number, because all other numbers are complex, right? So it is basically reading you in the complex numbers. So this is 3 I given simply, right? So real part is 3 and imaginary part is 0. That is equal to 0 only. So and other things are shown here. Same. Now our function is what? First write down like same thing that is given. Okay. Transpose. I will use transpose for this one first. What is the transpose one? M dot single quotation. Oh no, not double quotation, single quotation. Okay. So this means transpose. It is indirectly what I am doing. What I am using here, transpose syntax. Okay, this will perform transpose syntax. Right? Just now we seen. Okay, I am clicking enter now. Yes, what it shown? What it shown? It's shown just to transpose. It doesn't change any symbols. These symbols. It was not changed any symbols. As it is, whatever the number in this row, that is shown in the column, that is transferred to column. Okay, row elements are transferred to column numbers, these row numbers are transferred to column numbers, and last row numbers are transferred to last row numbers. So transfer this, the above operation was done only transpose, of a matrix, not changed any any symbols, any symbols, that is plus or minus, nothing it is changed. Okay, but now I am going to use another, the second one, the C transpose. See, C transpose, right? C transpose we have. Yes, C transpose. C transpose, that is equal to just a quotation mark, single quotation mark. So I am using this function for the simpleness. Yeah, I also will use this one. I also use this one. Yes, I also use this one. So now what I have to use here in the C transpose, what matrix, our base matrix is M, right? So I am using M here. Just take like M transpose, not here. I want to write here M transpose C, C transpose, M like C transpose, right? C transpose I will give like this. Matrix C transpose. Okay, C transpose M I am giving. That is complex conjugate transpose. Yeah. Now see, this is M matrix, actual M matrix. This is transpose matrix. This is C transpose matrix. Let's see, C transpose complex conjugate. So whatever the elements it has in the first row, that elements conjugate values, complex conjugate values in what? If it is 2 plus 1i, the complex conjugate value of this value is 2 minus 1i, right? This symbol will change. Yeah, that only it is happening here. See here, 2 plus 1i, it is become as 2 minus 1i. That is what? It's a complex conjugate of these elements. That means by using C transpose function, the resulted matrix will have the complex conjugate values of the original values. Okay, so yeah, this is same. The row elements will become as column elements, and column elements will become as row elements here, right? See, row elements and become as column elements. This is a transpose. What is a complex conjugate? What is happen here? This is a complex conjugate value. Why this came? This is complex conjugate value, right? So this is row values, and row values are same, but its its symbols are changed. So I can say what I can write here, what I can write here, using using transpose, using C transpose, using C transpose function, we can find complex conjugate of a matrix, complex conjugate of a matrix. See, this value complex conjugate 2 minus 1i, and 3 plus 4i means 3 minus 4i, 3 plus 2i means 3 minus 2i. This is 0, this is 0, and 3 plus means 3 plus 3 only. These are real values, right? Yeah, it's real values. And see, it is complex value, and it is become as minus, it is plus, and it is become as minus, it is minus, it is just 5y plus 5y, it is just become as minus 5y, complex conjugate. So complex conjugate of transpose is this thing. Okay, simply. And there is another function we need to test, right? So I am going to test same MCT, for example, function. I will take function that is M, just quotation, right? Just a single quotation we need to give to find the C transpose for the same operation to perform it. Yeah, what is that? In the examples I have taken M matrix here. For the showing, I am using A matrix here. So in the MATLAB direct live example, I am taking M, right? So I need to write MCTF is equal to M single quotation mark to find complex conjugate transpose, right? So that is what we are doing. So I given here already, this is the M matrix, original matrix. I am going to find, to check whether this function and this function will result same or not. Yeah, see, so this function also will become same. So the thing is, you you check here, if the matrix is a real matrix, like I cannot say real matrix, as a matrix elements are integers, integers integers without imaginary part, this both function, what is that, dot and hyphen, sorry, dot and single quotation mark and single quotation mark, both operators will result same, will result same, both operators will result same. But but if a matrix is complex, matrix have, if a matrix has complex values, we can see the difference, we can see the difference between both functions, between both functions. So because of that, when you are writing a code and complex code, and the transpose part also, so to transpose syntax also you are using in that, in the complex code, means you should be very careful which function you are using. For the static outputs, both function may be result the same, will give you the same results. While you are dealing with integer matrix, the elements are completely integers, no imaginary parts. But when your input might be dynamics, sometimes it has complete integers, sometimes it has imaginary parts like complex numbers also. That means you should be very careful which function you are using, right? Okay, thank you.